All right, so let's take a look at solving this system algebraically. Let's try to do it without using decimals, without graphing, to see where, what the lines look like. If they're coinciding lines that basically overlap each other, are they parallel lines that never cross, or are they intersecting lines that meet at exactly one point? So in this case, we have our two equations, y equals negative 2x plus 9 and y equals negative 2x minus 3. And if I wanted to pick a way of solving this system of equations, I think I'd prefer to use substitution on this case because I actually have two equations that are both solved for y. And think of it as if y equals one thing and if y equals another thing, that means that those two things have to be equal to each other. Okay. Another way of looking at it is I'm going to take something that y is equal to, the negative 2x plus 9, and I'm going to substitute it on the other equation for the y variable because that's what it's equal to. And when I do that, I'm going to replace the y on the left with negative 2x plus 9. I'm going to replace, sorry, I'm not going to replace, I'm just going to bring down the right-hand side and set those two equal to each other. Now, if I try to solve this, let's see, move the variables to the same side. So let's add 2x to move those to the left. Let's see, negative 2x plus 2x is 0. That's what I wanted. But on the other side, negative 2x plus 2x also equals 0. 0 plus 9 is 9. 0 minus 3 is negative 3. So you may recall that something like this happened when we're solving linear systems or linear equations with one variable. These are special equations. So in this case, it's a special system. It's one of those where it's not just one single answer. When we get a system like this, where we get an equation that like 9 equals negative 3, this is the case where we have no solutions. So in terms of what would this look like on the graph, this would be two parallel lines that have different y-intercepts, same slopes, they never intersect. Okay, so algebraically, this is what will happen, and we'll say no solutions. If we were classifying this system, we would classify this as an inconsistent system. Inconsistent because there aren't any solutions. Let's take a look at one more. All right, so here we have our system. You can see it on your screen. Things look to be lined up in standard form. The x's first, the y's second, then equals the constant terms. So I think we're going to try to use elimination to solve this. So another way of reviewing elimination method. The problem is when I try to use elimination right now, the way the equations stand, nothing eliminates. I add my equations together and I get something with x and y. So I don't want that. So let's go back and let's think about what do we have that would be multiples here. Well, I can see it looking at my x's that 6x is a multiple of 3x. I can also see it by looking at the y variables that negative 2y is a multiple of negative 1y. But sometimes I'm a little afraid of those negative numbers. So let's focus more on getting my x terms to eliminate. Well, if I already have 6x, I want the top equation to become negative 6x so that they add up to 0x, or just 0, making them eliminate. Let's see. So if I want it to become negative 6x, so what would I have to multiply this equation by if I want the first term to become negative 6x? Well, I know I'm going to have to multiply it by a 2 to make it 6x, but I have to make it negative 2 if I want to multiply right here and get negative 6x. All right, so I'm going to multiply everything in that equation by negative 2. I can't just multiply one part of it. I'm going to multiply the whole thing. I'm running a little out of space, so let's move this down. Multiplying negative 2 times 3x is negative 6x. Negative 2 times negative y is going to be positive 2y. And then negative 2 times 8 is negative 16. So there's my new equation. Here's my second equation that's going to stay the same. And now I'm going to add those together and see that my x terms are going to eliminate. 6x negative 6x adds up to 0. 2y plus negative 2y adds up to 0. Oh, wait, when things add up to 0, and I get 0 plus 0, it's 0 over there. Negative 16 plus 16 is also 0. Wow, everything zeroes out. I get an equation that is true. Remember on the last one, when my variables canceled out and I got two numbers that were not equal, I said no solutions. This time, when everything cancels out, it's not, I'm not quite saying that all real numbers are solutions like we did with regular equations. With a system, what it means is that you have two lines that overlap. They're those coinciding lines, that one is right above the other. They share every single ordered pair in common that's on the line. Not every ordered pair that exists, but the ones on the line. So what we say for this is we say infinitely many solutions. We're not quite saying that everything's a solution, but we are saying that there's an infinite number of solutions because every solution or every ordered pair on this line, on these lines that overlap, are the solutions. Okay, but there's still a lot of other ordered pairs that aren't solutions because they're not on the line. So we have no solutions when we get an equation that's not true because the two numbers are not the same. And we say infinitely many solutions when we get two numbers that balance out the equation. Usually that's going to be 0 equals 0.